All right, line P1, learning task 12, and it is going to be a 12a because we are going to have to break this one apart into the 4 different permutations that we are going to see as we go throughout here. What we are going to be doing inside of this one is we're going to be taking an isolation transformer. In other words, a single one of these transformers that looks normally like that. I erase all the rest of those lines. That looks like that has a 600 volts high side, has got a 120 volt low side, and what we're going to do is we're going to start interconnecting from one side over towards the other. And as we do so, we are going to start creating what we refer to as an autotransformer. The creation of an autotransformer is a little bit tricky for the analysis because in order to do that accurately, we are going to need to go over a number of new terms, as well as we need to go and just define once again when we're looking at a line versus when we're looking at a load. So I'm going to leave this page over here. This is the same one as your figure number 1. It's just I've cut this thing and placed these things side by side so that we can go and figure out what we have. And we're just going to go into this first little section over here. Figure 2 talks about, we're going to do an analysis on the very first one. But before we even do that, I don't even want to start trying to take a look at this until we define a couple of terms. The new terms that we need to go and define over here are going to be buck and boost. We are also going to go and relook at the terms step up and step down at the same time. Let's start by taking a look at the term buck and boost. Bucking is going to be any time that I've got transformer windings that are going to be in opposition to each other, where they're not working together, they're not aiding each other. Boosting is going to be any time that I've got some transformers that are going to be aiding each other. The transformer windings that are going to be, the fluxes are setting up voltages that are going to go and help each other out. The easy way to go and remember this is just, work off of a simple little word. So picture story here, whatever. Imagine that it is, a pre-COVID or post-COVID, whichever one's, better for you to imagine. And you and your friends are out for a night on the town. You end up at a bar, and on the way back from the bar, you just do something stupid. Nothing greatly illegal, but just, illegal enough that you are going to get chased by the police. Here we will draw police in with blue. Give them a little police hat or something like that. And so you and your friends, we'll add a third little friend over here, are running from the police. You do that thing where, when you run, the very first thing that you should do, as I've learned in the movies, is turn down the nearest alley. And so you do that. And what is at the end of that alley? Well, everybody knows that there's about a 12-foot high chain link fence. So here's the fence right over here. And so what happens is that as you're running along, you get to the fence first, and your buddy who's right behind you is going to go and help you. They're going to boost you over top of that fence. And then they're the next one at the fence, and so the other buddy is going to go and help them over top of the fence. And then what happens is you and the first buddy that got boosted over run off. What are you doing at that point? Well, you are bucking over that last poor friend of yours that you've left on the far side of the fence over there, okay? Boosting just refers to when we have got help. There was boosting to get over top of the fence. We're going to see boosting types of configurations where transformer windings help each other. We are also going to go and see bucking types of transformer ones where they don't help. Like in this example, where you and your friend run off, you leave him, we'll stick his hands behind his back because that's what's happening right now. It's a couple of handcuffs on there. Where it's just not helping the system. We'll still use it to accomplish what we need out of it, but the voltages are in opposition. That's buck and boost. Step up and step down, we've talked about that before. Step up just means that I'm coming in with a low on the in, and then I'm going to be coming out with a higher on the output. Step down just means that I'm going to be coming in on a high, and I'm coming out on a low value of voltage over there. What we are going to see in all of these transformers is we are going to have bucking or boosting, which means that my windings are either helping or hindering each other. And we are going to go and have a step up or a step down application out of these. We will label them all as we go through them. So leave some room on that very first one that you have over there. We're going to come back to that one. We'll label off each of these as bucking or boosting, stepping up or stepping down. Let's start with the very first one that they give us, though. Let me just erase all of this shenanigans over here. and we'll start with this first one. The very first one that they show to us over here is a 600 volt winding that we have and 120 volt winding, and we're making connection over here from my H1 over to my X2. And before we start analyzing that, what we need to do is we need to start by taking a look at just the transformer itself and determining what the rating is of every single component. They tell us on the very first one that it is a 15 kVA transformer. In other words, this top side of the transformer is good for 15 kVA, and the bottom side of the transformer is also going to be good for 15 kVA. So if we go and take that VA, 15,000, and if I divide it by my high side voltage, the 600 over here, I find out that that 600 volt rate, winding is going to be rated for 25 amps. And if I do the same thing on the low side, but I use the low side voltage of 120, I will find out that my low side is going to be good for 125 amps over here. Perfect. So those are going to be the absolute maximums. Will they necessarily be carrying that? No, but that's what they are rated to be able to go up to as far as current carrying capacity is going to be. We are going to treat these values that we have inside of here almost as if they were fuses. They're not fuses. This is a transformer, but we're going to treat it like fuses. In other words, we're always going to look at these as being a maximum current that we can pass through any one of these windings. The very first one that we have has connections between H1 and X2. Now, anytime that I have transformers that are designated with H's and X's, we know where our high and our low side is. And anytime that I've got 1s and 2s that are going to be behind the H1s or the X's, that's going to tell me about instantaneous polarity. We know that my H1 must have the same instantaneous polarity of X1. What creates X1? Well, H1 creates it. So X1 is always just going to have to follow along. It's bound magnetically to my H1 that we have here. Okay, so to analyze these, we'll start by just freezing time. We know that we have got a 600 volt AC source that's going to be placed across here. If we take that 600 volt AC source and we place it across there and we just disconnect this and disconnect this here and we get rid of that little ground there for a second, this would look pretty normal to us with what we're used to seeing, right? A AC supply, we've got this placed over top of there. What we're going to do is we're going to freeze time, and when we freeze time, this becomes a negative on my H1, this becomes a positive on my H2. We'll reconnect in this transformer over here. I'm just going to remove that ground just for the time being here. And when we take a look at that, if that's a negative, this is a negative, and if this is a negative, we cannot have a negative without having a positive, right? We have to go and have these counterbalancing forces over here. So this one is going to be a positive over here. We also see that we have then got to another negative, and then we go to a load resistor, and then from there, we come back to my H2 over here. In essence, what we've done is we have created this type of an autotransformer where we are going to go and have a primary that is going to be 600 volts over here, and where we are going to have a secondary that is going to be 120 volts, but now they're tied together, and so we're able to add, basically just to stack those voltages together to bring us out to a value of 720 volts. One of the easiest ways to analyze these is to go and make a conversion into a DC type of circuit. If I were to go and freeze my AC input over here and take a look at this, I could say that my H2 is a positive. That's what they're trying to show over here. H2. This one, H1, is going to be a negative. And if I go down here, this is going to be my X1. This one is going to go and be my X2. And if you take a look at the configuration, you'll see that this is a series aiding configuration that we have inside of here. In other words, it is going to be a boosting type of configuration. We have 720 volts on our output over here because of that 600 plus 120. And we have got 600 on our input. So what is my actual transformer application? Well, so far what we have determined, and this is A that we're working on, is that it is boosting. They're aiding each other. And it is going to be a step up. We start at 600 volts. We end at a value of 720 volts. So it's a boosting step up. Boosting and step up both end up being together on this transformer. However, they are not always going to be together. We will sometimes see, where we can have boosting step down, or we can have bucking step up types of applications that we will have. So don't treat them the same. Make sure that you understand what each is. Boosting just means these are aiding. The step up means that we're getting up to that 720 volts that we have. Let's go back into our analysis over here. What is the maximum amount of current that we can pass through any one of our windings? Well, that would be this one here could have 125 amps, and this one here could have 25 amps. If I were to go and take a look at that, I could see that all of my load current is in series with this 125 amps, which means that the maximum amount of current that I could deliver out to my load would be 125 amps over here. If I were to go and deliver 125 amps to this load over here, what would that mean that I would have for a total VA that this thing could go and drive out? Let's find out. We'll take 720, we'll multiply that by 125, and when we do so, we end up at 90,000 VA. 90,000 VA. VAN is equal to my VA out, which means that if I've got 90,000 coming out over here, and if I've got 90,000 then therefore coming into this thing. Once again, if you were to go and take a look at your currents inside of here, we would take a look at this volts and this amps over here. We're not even going to do the rest of the current analysis inside of here yet, because it makes more sense just to go and figure out what do we have in these lines here. That was that 125 that we said could be our maximum. And then we're going to take that 90,000 to this side. We do the same thing now, except we're going to work backwards from VA into amps. So that's going to be my 90,000 volts divide out by my 600 volts, which is going to bring me out to a value of 150 amps. So I know that my incoming and outgoing lines would have to be 150 amps. Now that I have these values over here, I can go and Kirchhoff's current law, the rest of this circuit over here, which means that we are going to go and take all the current into a node, make sure we get the exact same amount that's going to be coming back out of that node. Over here, I see I've got 125 amps heading in over there. What I see is over here is I've got 150 amps. Now, what is this section? Is this section a source, or is this section going to be a load on here? Well, you have to go and determine what is it doing. In our case, we are going to go and treat this thing as if it were a load. It's being delivered. It's getting current that is coming in from here, 25 amps that is traveling through here, and then traveling back out. And that 25 amps that travels through there is what fluxes our core, creating that additional 120 volts there that we can then go and add on to everything else. So this section over here is a load. Current always travels from negative to positive when it goes through a load, which would mean that the current that's traveling through here would be entering into this over here. I see I've got 125 amps entering from here. I've got 25 amps entering from here. There's only one exit, therefore it must all be exiting, and that adds up to become that vector sum of 150 amperes. If I take a look at the other side over here, I see I've got 150 going in. I know that I've got 25 going through there, which means that I must be diverting the other 125 down through here. And that makes sense as well, because we can follow that 125 through to here. This very first transformer over here is absolutely fantastic. What was the kVA size of it? It was 15 kVA, right? That was the ratings of this thing as a standalone transformer. No more than 15 kVA. But through this Autotransformer application, we are actually able to go and deliver 90,000 VA out of this thing. It's a 90 kVA that we have gone and created out of it. This is a 6 times increase that we are seeing out of it. This is not, like a theoretical only thing. This is actually the way these things happen in the real world. And this is once again why, the copper on these things is so light. We see that we're delivering 90 kVA, we're only using, 15 kVA worth of copper in order to go and do so. They also go through the current arrows over here inside of this one. The last thing that I do need to go and point out as well on this is we said when we were going through our current, this one over here was a load. What I did forget to go and do was talk about this winding over here. And this winding is a source, right? We're adding it onto that 600 volts. It's not acting as a load to that. It is acting as a source, as an addition to it. How does current travel through a source? It travels through from positive to negative. So I want you to go and identify this one here as being a source winding, this one here as being a load winding over here. We'll go back up to this one here. We'll just finish chucking in all the rest of the numbers over here. This one's going to be 720 volts, 125 amps that we can get out of it, and therefore it's going to go and be a 90 kVA connection. Note that we don't call it a 90 kVA transformer. We call this a 90 kVA connection that we have. Ultimately, it is still a 15 kVA transformer, but we're able to go and make a 90 kVA connection from it. All right, fantastic. Let's go and move on to the next one, B. Over here, we'll do that in another video.